All right, guys, so let's see how we would use the retrofit and RxJava libraries that we have implemented in the last lecture, how we would use them to retrieve our data from the backend API and show them in our list. Now, in order to do that, let's open up list view model. And in the refresh function, I'm going to remove everything we've done here, because that was just some data, some random data that we created locally to have something to display. But don't worry, we will have a lot more information to display after this lecture. Now, first thing I want to do, I want to create a private function, fetch from remote. Okay, fetch from remote. So this function will basically return the data from the remote endpoint. And I'm going to call this method from the refresh function. Okay. The reason I'm not putting all this functionality directly in refresh is because the refresh function, we will put some logic to determine whether we want the data from remote or from the database based on some conditions. Okay, so a lot more functionality will go into this one. But here is where we will actually use the Dogs API service, the retrofit service, to retrieve data from our backend API. Now, here, let's go ahead and implement this function. So we're going to say loading.value equals true. So the first thing we do, we set the loading flag to true. Now, let's go here at the top and create a couple of variables that we're going to need. So I'm going to say private val dogs service equals dogs service, dogs API service. And I'm going to instantiate that. Next up, we have a private val disposable, and that equals composite disposable, and that will allow us, the disposable will allow us to retrieve to observe the observable that the API gives us, this single, and not having to worry too much about actually getting rid of it. Okay, so that will allow us to avoid any memory leaks that might come with waiting for an observable while our application has been destroyed. And the way we manage that is that we have a method, a lifecycle method called onCleared, and here we will use the disposable.clear method to clean up everything we need. Right, so if we go back to our fetch from remote, we will use our disposable.add. Okay, and here we will call dogs service.getDogs. All right, so this will return us the single that we have defined here. Now, what do we do with that? Well, first thing we do is we set that call to be on a separate thread rather than on the API thread. The reason for that is that we don't want this call to be made on the API, on the main thread, because that will basically block our application while the call is retrieved, okay, while the call is finished. And that will basically block the user for however long the communication with the backend API happens, okay? Now, Android guards heavily against that. And if we try to do anything like that, our application will immediately crash. So we want to avoid that by passing this call to the endpoint on a background thread. And the way we do that, we have a key method here that is called subscribe on. And this subscribe on takes a schedulers.new thread, which will basically say we want this process to be done on a background thread. However, the result of this process needs to be processed on the main thread of our application. So in order to actually display it, we need to have it on the main thread and not still on the background thread. And of course, we have a method for that. and the method is called observe on. And for the observe on, we have Android schedulers dot main thread, and that will give us the main thread of our API, of our application. Then we have subscribe with, okay, and here we need to pass the observer that we want to observe this single, okay, and here we have object of type disposable single observer. Okay, the disposable single observer will basically get a list of dog breed. Okay, we need to create it and then we need to implement it. Now, in order to implement it, let's go ahead and click or type option return, or if you're on a PC, it's Alt Enter. And here we're going to implement the members on success and on error. There we go. So on success, we actually get the list of dog breeds. On error, we get an error message. So what do we do with on success and on error? Well, we simply update our mutable live data. So we have dogs.value is going to be whatever our dog list is, which is T for some reason. Let's we should rename that probably. We should call this dog list. Okay, so we can set the dogs.value to dog list. And then what else do we need to do? Well, we need to put dogs load error dot value equals false because we didn't get an error this time, and we need to set the loading dot value to false because the loading has finished. Now, what happens in on error? Well, the dogs load error dot value equals true. Then the loading has finished, so value equals false. And we should probably do e.print stack trace just to have a trace of that information being displayed somewhere. So this will just log the error in our logs. Now, that is all we need to do. So here we should already have the value of the list of dogs from the remote endpoint. So let's run this application and see what we get. All right, so it seems like we get an error. So for one, I'm happy that we got this error because it allows us to test our error path. Okay, so we have ended up in this case, we got an error, and we can see that the functionality is actually correct in the case of an error because we simply display some error loading, some error message here. Now, this gives us a good opportunity to actually implement this refresh functionality. Okay, we can see that this pull to refresh does something, but it doesn't actually perform any function in the background. So that allows us to go nicely into refreshing the data here. So in order to put in that functionality, we're going to go to our list fragment. And here, we're going to have refresh layout dot on refresh listener, set on refresh listener. And here we're going to do a couple of things. So first off, we're going to say dogs list dot visibility equals view dot gone with a capital G. Let me just close this because my system is running a bit slow. Right, so dogs list dot visibility equals view dot gone. Now, list error dot visibility equals view.gone as well. So what we're doing here is we're starting the refresh process. Okay, so the error must disappear as well. Now loading view.visibility equals view.visible. So this needs to be visible. Next up, we're going to do viewModel.refresh, and we're going to say refresh layout dot is refreshing equals false. So this is simply going to make the little spinner at the top disappear, but we will still have the loading view spinner here. Now, before I run this and do the refresh, actually let's run it now and see how the refresh works. We should, even if we refresh, we should still get the same kind of error message. We just won't see this little spinner running. All right, so our application is running. Let's try to refresh. There we go. So we have refreshed. We can see the spinner 1 millisecond and then the error message again. Now, if we look in the Android manifest file, we are actually missing a required permission here. Because we are accessing the internet here, we need to declare inside the manifest, we need to declare that we need to use that permission. So we're going to create a tag here that says uses permission. And if we simply type internet, we should already get a suggestion for the internet permission. So that is one of the issues why this is not working for us. Let's see if that solves our problem. All right, so it's loading, and then you can see that all the information from the backend has been retrieved. Okay, now of course we don't have the image yet because we haven't loaded it, but the URL is there, and we will load images here shortly to make this look better. But already you can see that all the actual dog breeds are already here. Okay, so this starts with Affenpinscher. And if we look here, we have the Affenpinscher. Okay, then we have the Afghan hound and the African hunting dog. Okay, so this is the hound and the dog. So all this information now actually comes from the backend, and that allows us to display this information pretty much effortlessly, right? You can see there's a lot of information here, right? There are maybe 200 or something dog breeds in this list. So that is basically how you would use the retrofit service, retrofit API, to set up the endpoint that you want to call using the get method into a method, or rather here, a method that you can call in your code. Where did we call that? We called it here to get the information from the backend on a background thread, and the answer, the response, is processed on the main thread using a single observer that gets the value on success and passes it through a mutable live data to the view, where the view actually displays it correctly based on the information it gets from that live data. And also, importantly, we don't need to worry about disposing of the observable because when it's cleared, we automatically do that. So we don't need to worry too much about memory loss and things like that. So this is actually, it might seem a bit complex and convoluted, but it actually helps us separate functionality in a really good way, because that functionality is separated on one hand with the API service. Okay, so the communication is done by the API service. This is the model part of our code. This is the view model part of our code, where we simply call the service of the model and get the information. And then there's a clear separation between the view model and our view, where the view model doesn't know anything about the view. It doesn't care about who is actually consuming this data that it produces, but the view retrieves that information and does what it needs to do with the proper data. So there's a clear separation between view, model, view model, and model. Okay, I hope that makes sense, and I hope you can see how we use the MVVM architecture to structure our code in a really clean way. And that allows us to extend this functionality as well. So for instance, if you have another endpoint of the same base URL, you would simply add a function here to retrieve the second endpoint. You would add a function here to return that result to the view model, and you would add a function in the view model to implement that that call to the endpoint here. And then whatever view is attached will retrieve that information and do whatever it needs to do with that information. Okay, so this is a clear separation, and it allows us to scale the application really nicely in a really nice coordinated way without mixing information on on multiple, let's say, layers of our application. Okay, this is structured really well so that each part of the code goes in the right place, and it allows us to grow. One more very, very important thing is that this kind of structure of the code allows us to test the applications really nicely. Okay, so we can mock the API, and then we have everything else we need inside the view model. We don't need to implement any Android functionality. Okay, so that allows us to test this view model really nicely because there's a clear separation between the view model and the view and the model. Okay, so we separate the functionality here. That will allow us to test it later on. Now, of course, this view model is, even if it doesn't know which view is attached to, the general recommendation for this architecture is that only a single view is attached to a view model. Okay, so in principle, yes, you can have multiple views that use the same view model. In practice, though, you would have one single view that is attached to one view model. Now, of course, this one single view can evolve over time, so you could have a second version of this view that attaches to the view model, but at any one time there is only one view attached to a view model. Okay, you shouldn't have, it's kind of a bad architecture practice to have multiple views attached to a single view model. And that is the reason why we will actually implement the for the detail fragment, we will implement another view model. Okay, that is why we have implemented here another view model that gets the data in a different way rather than using the same view model, because in principle we could put this function inside our list view model and work from there, but we actually want a separation here so that we can test this functionality in a separate way from this functionality, whatever functionality we will eventually have here. Okay, so I hope that makes sense. I hope it's not too abstract. I've tried to implement an example of how you would use this in this architecture in actual practice to get information from a live API backend. Okay, so we're going to stop here with this lecture. We're going to continue to add more functionality in the next few lectures, but for now I think this is enough. As always, thank you for following along with these lectures. Thank you for building your code locally, and I will see you in the next lecture.